Hello, my dear friends. My name is Shri, and today, along with my team members Gaurav Singh, Shreyas Tute, Shreyas Damodar, we are excited to present our project, CreadChain, a decentralized credential verification blockchain, guided by Dr. N.M. Kondoi sir. We have developed a system designed to transform trust in academic and professional credentials. The problem. Let's start by talking about the problem we are trying to solve. The current system for verifying credentials, whether it's a university degree or a professional certificate, is facing a crisis of credibility and efficiency. First, the process are incredibly slow and manual. It involves time consuming paperwork and human intervention, leading to significant delays for students and employers. Second, there's a major risk of fraud and tampering. Centralized databases are prime targets for hackers, and physical or digital documents can be easily forged or altered. Finally, the system is completely dependent on intermediaries. We rely on universities or third party agencies, which adds unnecessary cost and complexity to what should be a simple verification check.
Our solution and objectives. Our solution is CreadChain, a system for decentralized tamper-resistant credential management using blockchain technology. Our goal is to fundamentally change how credentials are issued, stored, and verified. We have four primary objectives. First, decentralization and immutability. To store credentials securely on a distributed tamper-resistant ledger where they can't be secretly altered. Second, eliminate intermediaries to enable direct peer-to-peer verification between the institution that issued the credential and the employer who needs to verify it. Third, real-time access to provide instant verification for anyone, anywhere in the world. Fourth, enhanced transparency to log all verification activity on a public ledger, creating a clear and auditable trail. It's important to note that our current scope focuses on this core verification protocol. Then the system architecture. So, how does it work? Let's look at the system architecture. There are three main actors and two core technologies. The actors. First, issuing institution like universities act as trusted nodes that create and digitally sign credentials. Second, the student holders. The student holders are the owners of their credential. They store their identities and control who gets to see their records. Third, verifying employers or third parties can instantly request and validate the authenticity of a credential. And the technology. The blockchain ledger is where the magic happens. It records tamper evident proof of each credential, ensuring no one can alter a record once it's been confirmed. Second, the IPFS stands for Interplanetary File System. It is used for off-chain storage to keep the blockchain fast and cheap. We can store the actual encrypted document on IPFS and only put a unique fingerprint of it on the blockchain.
So next is the presenters. The architecture is powered by five core modules, including the blockchain layer, smart contracts that enforce the rules, and a verification engine for queries. The data flow is simple and secure. First is insurance and signing. An institution assigns, issues a degree, signs it digitally, and generates a unique cryptographic hash like a digital fingerprint. Second is the off-chain storage. The actual document is stored on IPFS. Only that small, unique hash is sent to the blockchain. This saves space and memory. The third one is the on-chain immutability. The hash is recorded on the blockchain where it becomes a permanent and unchangeable record. Fourth is a real-time verification. An employer can then take a credential, generate its hash, and instantly check if that hash exists on the immutable ledger. If it does, the credential is authenticate, authentic. Next is the present data. We built CreadChain using a modern technical stack. We used an Ethereum private network with smart contracts written in Solidity. The backend runs on the Node.js, the frontend on React, and of course, we use IPFS for storage. Security is paramount, so we use SHA-256 hashing and digital signatures to ensure data integrity and non-repudiation. And the performance results speak for themselves. First is the verification time is nearly instantaneous at 1 second. Next, our network achieves a throughput of 30 to 50 transactions per second thanks to our choice of a proof of authority consensus mechanism. We achieve an 80% reduction in storage cost by using IPFS for off-chain storage. Transaction latency. The time it takes to issue a new credential is only 2 to 4 seconds.
Conclusion and future directions. In conclusion, CreadChain successfully demonstrates a viable platform for creating tamper-proof, verifiable, and immutable records. We have proven that this model delivers significant efficiency gains by reducing verification time and eliminating intermediary costs. Looking ahead, we have an exciting roadmap. We plan to integrate with decentralized identity frameworks to give users more control over their personal data. We aim to build cross-chain interoperability so credentials can be verified across different blockchain networks. For enhanced privacy, we will implement zero knowledge proofs which will allow verification without revealing the underlying data. Finally, we will add some smart contract logic for credential revocation. For cases where a credential needs to be expired or invalidated. Thank you for your time. We believe Cred-Chain is a powerful step forward in building a more trustworthy and efficient world for academic and professional credentials. Thank you. Now we will move forward to the presentation of our project on localhost. This is our UI where you have options to upload a document that will be stored uh, with the help of IPFS. And there is also option for verifying the document. Now let's see the actual practical. Here we are creating a file named block.txt. Now this file would be fed to our application. As we have fed the text file to our application, it will generate its hash. Now our hash is generated successfully and that hash is stored with help of interplanetary file system locally. Now let's verify the document. We are uploading same file to verify, which is block.txt. As we have seen, the document is now correct and there is no tampering in the document. Hence, our hashes have matched properly and the document verification is done. Now let's try tampering the block.txt file. Now we have added the fundamental word in our block.txt. It means that it is no more our earlier block.txt file. Now we will feed this file one more another time to our application. Document not verified. It means that hashes do not match because of tampering, and this is uh, the complete verification of our uh, certificates and documents. Thank you.